This is a really nice question on the floor function. So some graphs that you would be expected to be able to draw, y equals x, y equals sine x, except we're working in radians, they have to know about that as well. But then we're applying the floor function to different parts. That's the unseen bit. Let's give it a go. So we could, I suppose, draw the line y equals x on there. I'm not sure that's going to be particularly beneficial. Now, we're definitely going to be plotting along like 1, 2, 3. These are going to be where things happen, and there's going to be a pi just beyond the 3. And minus pi here. So when x is 0, the floor function just gives 0. When x is 1, we're going to get 1. So I can also go up by some amounts here. 1, 2, 3. Now what's going to, I'll go down a minute. Let's deal with the positives first. So the floor function applied to 0.5 is going to give 0. Actually, this is just going to go along horizontally until we get to 1. Note, when we get to 1, actually it jumps up. That's what it means by a discontinuity. And to show this mathematically, we put a little circle, open circle here, and then do a dashed line going up to the full circle, just to show that it is jumping vertically up. And then 1.2 would jump down to 1. Actually, we're going to go along horizontally again until we get to 2, and it will jump up. It proceeds just like this for the remaining parts. This here will include pi like that. Now, when we have something that's just slightly less than 0, actually it's going to jump down to minus 1. Open circle here, and then go horizontally across until we get to minus 1. And I can put in the minus 2, minus 2, minus 3, minus 3. And then when it goes slightly less than minus 1, it's going to jump to minus 2. And the same here. Then, okay, in this case, when we go slightly less than minus 3, actually, it's going to jump to minus 4. Hit pi there. And that is our answer to part 1. That is y equals the floor function of x. On to the next one. We're asked to plot y equals sine of the floor function of x. Well, we have the floor function of x to look at. So again, some key values are going to be taking place because it's the floor function of x. It's going to be again at 1, 2, 3, 5. And then we just need to think about finding sine of each of these values. So obviously sine of 0 is 0. And so it's going to go all the way along like this till we get to our open circle again. But then we're going to be finding sine of 1, sine of 2, sine of 3, and so on. So we need to think about this in some detail. So I thought sine 1 in radians is going to be sine 180 over pi in degrees, which is slightly less, but roughly equal to sine 60. Okay, it's going to be a bit less because it's 180 divided by 3.1, but it gives us a ballpark. So maybe around 0.8, because sine of 60 is 0.87 or something like that. We don't need to put that on exactly, but it's just good to have a feel for where it is. Now, it's sine of pi over 2. we're never actually going to get that here because of the floor function, but that is equal to 1. And pi over 2 is 3.14 divided by 2. So it's going to be about 1.57. It's actually a good idea to get the sine graph drawn. But I'm going to illustrate my point in a second. So this is pi over 2, which is about 1.57. Now we can see sine is symmetric about this. So sine 2 is going to be slightly higher than sine 1 because this is closer to 2 than to 1. That's a useful result, and that will be expected on our diagram. Sine 2 greater than sine 1. Sine 3, meanwhile, is going to be close to sine pi, which is 0. The sine 3 will be smaller. I think we can make a pretty good sketch for the positives. We'll look at the negatives in a minute. But we're going to get sine 1 is still going to be quite big, actually. So maybe, okay, it's just all relative now. I'm actually not going to write what value I think it is. I'm just going to say that this here is going to be sine 1. And it is going to jump up to that value and go along like this. And then jump up just slightly, sine 2. And then sine 3 is going to become quite small. So it's going to be like down here somewhere. And we're going to go along and actually going to have a value here as well. Now we can do very similar with the negatives. So we've got the period between 0 and -1 is going to jump down to sine of -1. And remember, sine, I didn't draw it on there, but sine is an odd function. It just basically reflects in the x-axis for negative values from what it was for positive values. So this is going to equal minus sine of 1. Open circle here. Like that. And then in a similar way, sine of -2, it's going to be minus sine 2. It's going to jump up a little bit. And then sine of -3 minus sine of 3. So again, close to 0, but this time negative. This just leaves us the region from minus pi to -3. But look, the floor function makes x, the floor of x, become -4 here. So actually, we need to investigate sine of -4. And that is going to be minus sine of 4. It's going to be easy to deal with sine of 4, Phil. Because let's look on the sine graph. Here is pi. So actually, 4 is going to be a bit further on. So this is going to be greater than 0, since sine of 4 is less than 0. And furthermore, like sine of 3 was quite close to 0. Sine of 4, what should I say, minus sine of 4, is going to be greater than sine of 3, since 3 closer to pi than 4. But minus sine of 4 is going to be less than sine of 1. Well, we can write that sine 4 is going to be approximately equal to sine pi plus 0.85. And then that is going to be the negative of sine, so minus sine of 0.85. We use the symmetry of the sine curve. And so sine of minus 4 is going to equal sine of 0.85, and that is going to be smaller than sine of 1. Okay, so I think we're ready to just finish it off. It's going to be, so that, remember, that's sine of minus 4. So we're going to get a value that maybe goes, let's put it here, goes along. And that's our final answer. Whilst our sketch is pretty clear, I think, let's just clarify a couple of things. We had sine 2 as the largest out of all the values, and that was bigger than the next largest, sine 1. That was then bigger than sine 4, which we showed was bigger than sine 3. All of these, sorry, this was sine of minus 4, just remembered. And then this was bigger than 0, which was then bigger than sine of minus 3, which was bigger than sine of minus 1, which is bigger than the smallest value, sine of minus 2. 2 to go. This is when we start applying the floor function to the entire function. Okay, so actually it's less about x being 1 and 2 and 3, and now more about what sine will equal. So let me draw a little sketch of sine. Actually, I'm only interested in minus pi to pi. So we can see that sine between here and we're not including that value is going to be between 0 but less than 1. And so our y equals the floor function of sine x is going to be 0 for all of those values. I can put a value here, and then I'm going to be going along all the way to pi over 2. This is going to be pi. So it's just going to go along like that. At pi over 2, we're suddenly going to get 1, and it's going to jump to here. So this is an open circle. This is going to be 1. But straight after, it's going to jump back down and then decrease all the way to pi. So actually, that is what it's going to look like. And just draw a dotted line to show that is our discontinuity. It's basically y equals 0 except to pi over 2 where it jumps to 1. That is it. If we now look at the other side, okay, I can see that it's going to be minus 1 at minus pi over 2. But actually, because of the floor function, it's also going to be minus 1 for all of these values. So there's going to be an open circle here, then it's going to be going along. And then actually it's going to carry on all the way to minus pi, because it's between 0 and minus 1. It's going to jump back to 0 here. But I didn't even need to put that open circle in. It's just going to be y equals minus 1 until we get back to minus pi, and it jumps back to 0. That is our function for 3. And then finally, we've got the floor function of 2 sine x. Okay, so some points we can put straight on. At 0, sine is 0, so we're going to get 0 here. pi over 2, it's gonna jump up to 2 actually. Because sine of pi over 2 is 1, and 2 times 1 is 2, but that is going to be the lone value at 2. Now, what is going to happen at other values? Well, let's look at when 2 sine x is equal to 1. That means sine x is going to equal a half. X will then equal pi over 6. We get another solution, pi minus pi over 6. So 5 pi over 6. So the sine function at the floor of it, the floor of 2 sine x. Well, up to this region here, up to pi over 6, I could change this to a 2, and then this to a 1. This is now y equals 2 sine x. So the function is going to, without the floor, is going to take values between 0 and 1 up to pi over 6. And therefore the floor function will just be this horizontal line. But at pi over 6, it's going to jump up to 1. Because then we're going above a half. Or sorry, we're going above sine x equaling a half. So 2 sine x being above 1. And it's going to stay above there, but between 1 and 2, except for this 1 point. So actually it's going to go along like this. There's going to be an open circle here. It's going to temporarily equal 2, a bit like what we had on the left. And then it's going to, sorry, this should actually be a straight filled in line. And we're going to go all the way along to here until we get to 5 pi over 6 when it again goes below the graph. So this will be a filled in circle, but straight after we jump down, we open circle, and then go horizontally along to pi. Oh, that is our function. Now something similar is going to happen on the other side, but remember when sign becomes negative, it's going to straight away jump down to -1. There's going to be this discontinuity in open circle, and it's going to go horizontally along like that. So whereas 2 sine x equal to -1, and be where sine x is minus a half, which is x equal to minus pi over 6, or minus 5 pi over 6. So we'll again get to this pi over 6, and then actually at that point we're going to have it's going to, just trying to think, it's going to go along at pi over 6. It's actually going to be equal to 2 sine x is going to equal -1, so that'll be filled in. But straight away after, we're going to be between, here we go, we're going to be between -1 and -2, so it's going to jump down to -2. So it would be an open circle, sorry, there. Sorry, I have to really think about this. Then it's going to go along. What happens at pi over 2, minus pi over 2, 2 sine of minus pi over 2 is going to equal, that is going to be -1, so we're going to get -2. So actually nothing happens there like it does in the other one because we're dealing with this floor function. But when we get to, let me put that in there. So that is minus pi over 2. Sorry, that should have been minus pi over 6. We're actually going to carry on until we get to here. minus 5 pi over 6, where it would jump back down because it's going to be a half there. Going to jump back down to minus 1. And then after that, it's going to be going along again like this. So no little jumps this time either side because it just it was below minus 1, but less than minus 2 until the point where it hit minus 2, but that still gives us the floor function equal to minus 2. That is our answer. Yeah, I stumbled a little bit there trying to explain it because there's a lot to think about. But these are your graphs. Really interesting question. Hold on.